All right. Hello, everyone, and welcome again to another talk from our AI series. Today, we are joined by Sanyam, who is currently a deep learning engineer at Weights and Biases. And we are very glad to have you. I'd like to share the background story about how this session came to be. A couple of weeks ago, I talked about Weights and Biases to my research group at one of the group meetings. I've been using it for a year, and I've been very, very happy using it. And then after the meeting, my advisor, Fatma Hoja, tweeted about this. And then the Weights and Biases Twitter account reached out to us after receiving this tweet, and they kindly offered us this session. All of us here train lots of AI and deep learning models. And I believe this tool is basically a great, thing to use, and it makes experiments easier and makes life much, much better. And so we're very excited to this session, and we're very happy to have you here, Sanyam. And without any further ado, the stage is yours.
Thank you so much. We do try to be super active on Twitter. And then when I heard this is at Fatma Ma'am's lab, I was like, I need to host this. Whoever was hosting, please let me do this, because I am a fan of her work. And I was telling to the people before we started recording, hey, I'm not as smart as you all. I'm not a master's student. I'm not a PhD student as well. I know how smart people are around Fatma Ma'am. So please excuse me, because I'm not at anyone in this call's caliber, so I apologize in advance. I'll assume my screen is visible. If it's not, please interrupt me. But hey, everybody, I'm Sanyam Bhutani, and thanks for the kind introduction. I'm a deep learning engineer, and I lead the community effort here at Weights and Biases. I want to talk about reproducible machine learning, and I'll try to uncover a few features around Weights and Biases, how we are trying to make our dent in the universe, how we're trying to help make research more reproducible. I put some links in the chat, which I can also send over. I had the chance to interview Fatma, and we also spoke about research, how to approach all of these things. So I'd love to share how we think we can make a difference there by making stuff more reproducible while making it a minimal effort for everyone. So here's the agenda that I have planned for today. I believe I'll leave around 10 minutes towards the later half for any questions and answers. I don't think anyone in this call would need the introduction, but I'll quickly go over why there's a reproducibility crisis, where all the issues lie and what are the missing areas in the current domain, broadly speaking, if I may. What are the barriers and benefits, and how can Weights and Biases help you all? Also, please feel free to interrupt me during the presentation as well. I'd love to keep this interactive. So here's my background. Like I said, I apologize. I'm not a researcher. I just drink chai and I make content for the community. I started basically with blogging. Then I got bored of it because it reached a large audience. So then I started a podcast, which surpassed the blog. I got bored of it. Now I'm trying to do the same with video. And then I'll write on my resume, I'm a full stack content developer for machine learning. That's my end goal in life. Outside of this is not fine as a background, right, for all of you. But outside of this, I come from a Kaggle background where I used to train a lot of models. So I had this rough start in machine learning where I didn't get a lot of guidance. I believe many people are like that. They just jump into the field because it's so exciting. It's so fun to train models. You see all the hype around it. I got hooked to it. I got excited about being able to predict stuff. So I started with Kaggle, and I made these mistakes that haunt me still that are around reproducibility. So I'll ask everyone to type a yes if they relate to this stuff. And of course, this is not fine, but how many of you all have used spreadsheets like so for tracking experiments? I see Fatma's hand going up. As you can see, like the problem, you always aspirationally start with making it very detailed, right? You want to track different architectures. I labeled time around experiments. I labeled all that stuff. And then this is like a mix of Hindi and English. I'm just writing check the notebook, and I don't even recall which notebook was this. Fortunately, it was exactly about 2 years ago. So I would hope that I've improved since. This used to be my approach to tracking experiments, and it gets real messy really fast, right? As we start to train more experiments. I grabbed this screenshot from my Kaggle profile. where I was being quote unquote comprehensive. So as you can see, there's absolutely no detail. If I send this to you, neither will I, nor will you be able to tell what was going on here, or it would be so thorough that I still can't tell what was going on here. I ensembled a bunch of models, which is really common in the world of Kaggle, and I still can't tell what was I trying to do here because I absolutely have no context here. I also, this wasn't just true to my experiment tracking approaches. My smartness extended beyond it, which was towards tracking code and datasets. So instead of documenting code, I would just fire up a new IPython notebook every time. And this was my super smart approach towards sharing models and model weights. I would just telegram them to different people. Fun fact, Telegram doesn't have an upper limit, I believe. So you can share as many model weights as you want. There's an E-day on the left. You can see IPython notebook towards the right. I'll admit, as a fresh student of machine learning, right, I wasn't excited to learn GitHub. That's for later, right? When I get a job, this is how I experiment really fast. So this was my smart approach towards sharing everything. But again, this is not fine. I can't tell what I was doing, even though it might have been interesting work. I remember I was trying to dynamically resize images while working on a project. And now I can't say anything about it, even though that might have been an interesting experiment to say the least. And all of this knowledge then gets buried in there. This brings me to the point that there's a reproducibility crisis. And I did also discuss this on the podcast with Fatma. We were talking about this, but I don't think anyone here needs that premise. There's limited incentive, I believe, to sharing your work. Also, there's a terror of making your code available. We've seen papers, we've seen, I want to quote the batch norm paper, which had different issues. We've seen this repeated multiple times where there was, I remember this Twitter thread where there was a bounty and someone said, if you can reproduce this paper, please, we'll Venmo you some money. And towards the end, only the authors shared their code by themselves. And this again causes problems, right? We need to be able to build on top of each other's work and not really spend more time trying to recreate what they did. Instead, we want to accelerate our work. And that towards the end just improves everyone's efficiency, right? Instead of ensuring that you're just making sure what's been done has been done, you can build on top. The IP gets retained. Again, that's a different discussion, but you don't have to worry about this stuff as long as you follow the right licenses, and it improves the validity of the results. If I can just download and run your code, that makes me believe it much more. We've again seen those places as well where people open source the work, but if you go to the repo, that's empty. And we all have hit our heads, we face palmed at that points. Again, not to say anything bad against anyone doing this, there's no incentive around it because it's also much harder. That's because there's so much to do here, right? You need to track your data, you need to track your code, you need to track your results, you need to track your hyperparameters, you need to track what was that architecture you came up with late on a Friday night. And no one really remembers that amongst the 1500 experiments and 2000 meetings we all are going through every day. So all of this setup was to bring me to an introduction around weights and biases. There are a few ways of solving these. First of all, source control, which is something I'm still not good at. So I just somehow find those getting started blogs and just copy the commands from there. And then I realize I'm not good at it. So that's one of the ways you can use GitHub smartly. You can also use weights and biases to capture hyperparameters, to capture your code, metrics, dataset, and models. And if you are brave enough to bomb your NVIDIA setup, I would encourage you to also try Docker. I'm not courageous enough because I'm always terrified to reinstall CUDA. So I try to stay away from that. So what is weights and biases, and why have I been ranting about reproducibility so much? We really think this is a missing piece in the current machine learning puzzle. And again, to credit, this has been developed by the company. I say we as a company have been concerned about this. And there are these go-to tools. For example, if you've collaborated with anyone in the industry, you would know Salesforce is synonymous with sales teams. Jira is synonymous with engineers. No one likes those tickets, let's be honest. And there's this missing puzzle. What's the next thing for machine learning? That's what we're trying to be, the missing puzzle that can help fast track your research, help make your life easier. So after a while, I thought memes give better context. So that's what I'm trying to do here. It's this infinity gauntlet that can snap your reproducibility problems away. We try to help you with experiment tracking, collaborative analysis, dataset versioning, and model optimization. These, like I said, I was setting up the premise because these are the problems that exist around the experiments we run, right? It's hard to keep a track of what hyperparameters we're using. You don't always remember your dataset versions that you were trying. And honestly, no one has the time to write blog posts. So how can we make it easier? We call our products the following names. We help you track all of these things, and we are quite framework agnostic. So we have built-in integrations with PyTorch, TensorFlow, Keras, scikit-learn, FastAI. I think just these four basically cover all of the frameworks that most of the people in this call would be using, right? And the idea is to give you one line of code where you can just add a callback and everything else is taken care of. So just using 3 lines of code where you install the API. So it's available on pip. You can install the package, and we're really open to feedback. We're still on the, I believe, 0.12 version of the API. So it's still under heavy development, and we're quite driven by the community for this feedback. I see Fatma's comment about KNet. Do you want to talk about it now?
Maybe in the end.
Okay. I was reading that paper yesterday, in fact. But we try to solve this problem just using a few lines of code where you can just install the package. All you have to do is initialize your project. So there you mention, let's say you're working on GPT-4 and you're at this awesome research lab that's capable of doing that. Because you're at that lab, you can run 900 epochs on a batch size of 2048 since you're training GPT-4. Again, not to throw any dirt. I'm just trying to be funny here. And after that, you can log metrics using wandb.log function. So just using these 3 functions, basically everything is mostly taken care of for you. So from here, I'll jump around and go to different tabs where I have dashboards open. So inside of your weights and biases profile, you can see all of these things going on. And if you're interested in checking out, I would encourage you to go to the quick start demos here. I've also shared them in the chat and I can send the links later. Typically, you start with a dashboard, which would look like so. This is a dashboard by our CEO. So I think we're in good hands. The first thing I mentioned, you can track your experiments. So if I go to the code, which is also captured here, this is in Keras. And all you have to do to capture everything here is just import a wandb callback. And you can pass it on when you're trying to train the model. I don't think I need to tell everyone how to do that. So just passing the wandb callback, most of the things are taken care of. And what are the most important things that matter to you here? You can already, through this dashboard, capture all of your losses, your validation accuracy, and see how's the training going. If you're not happy with this, this is completely customizable. So Zoom always interrupts the mouse movement. I'll get that out of the way, but you can move things around. You can add panels. You can add more charts. You can change stuff around. I see your hand being raised. Please go ahead.
So I was wondering, when you talked about configurability, can I add to these graphs things such as the my gradient norms and the weight norms, or other custom things that I want to track about my model, and how would I go about doing that? That was question number 1. Question number 2 is, how often do these things get sampled? Is that also
Great.
customizable?
Great questions. Yes, both are customizable. And you can absolutely log your gradients as well. I'm trying to recall if it was captured in this example or not. But inside of the documentation, it's I think it's mentioned how you can capture all of those details, and you can configure how often do you want to capture these things as well. One thing I really like is you can also set email reminders. So when your runs fail, so that you don't end up with a huge AWS bill, you can also set up an email or a reminder, or you can connect your Slack where you get notified. So you can track all of these things.
And
does that answer your question?
Yes. One more question. So the screen that you were showing us reminded me of TensorBoard. At some point, could you sort of compare and contrast the two as well?
Yeah, I'm happy to. I'll probably just cover the features and then we can discuss that if it's still not clear. Awesome, I'll continue. So I was talking about this is quite configurable as well. So if you want to capture something that is not already taken care of here, I can add another bar plot. And let's see, what do I want to capture here? Again, this is off the top of my head, so this might not be the smartest thing, let's say. Let's say just another loss plot, and you can add all of these things here as well. You can completely configure the charts as well. If you want, you can go around and change these. The thing I always like to do is, I remember once on Twitter, Fatma was making fun of me because I don't use my GPUs to the best extent. We had a nice exchange. So I always like to poke around different people's system settings and I can get a nice look at how are things going here, which GPU do you have? They don't have any GPU. That's I definitely make fun here. But this is quite useful because you can then take a look, and if you're trying to maximize your resources, they should always be at 100%, right? And then you can go back and benchmark your code. Let's say if your GPU utilization is ideally under 70%, that means you're messing up somewhere. Theoretically, it should be at 100, but we don't always write the most optimized code. So you can take a look at all of those things as well. While you're logging, you can also, apart from the things we discussed, capture many other things as well. So this is from a self-driving car example, I believe, and I wanted to highlight that you can also capture different masks while this loads up. Let me actually refresh this. So once this loads, I want to show that there's a nice depth cam view as well that gets captured. And again, this is totally customizable. You can decide how much of this you want to capture and at which step do you want to capture. So you can see how do these change with steps in your training and how are these affected as your model gets trained. Hopefully they get better, right? The more insights into what's happening behind the scenes is better. And again, you don't have to wait for your model to finish training, right? You can see these as they come in. And you don't always have to be connected with your machine as well. I know many users just use their mobile phone while they're away from their desk to stare at the metrics as they come in. And earlier I was talking about all of these different things around tracking your architecture, tracking your dataset version. So we also capture what architectures were used. And if I head over to sorry, I'm confusing myself. I wanted to show this one where I wanted to showcase how are the artifacts captured. So I wanted to point out that we also capture different artifacts, which means you can take a look at what validation set was used. How did you set that up? You can add metadata. You can take a look at the graph view, which tells you how are these being included in your model. If you have a complex pipeline, that also gets visualized here. So you can track your experiments. You can see all of them inside your dashboard. I've covered that so far. You can, of course, filter out based on which ones do you want to see. So as you can see, I can see all of my experiments here. If I want to just see a few of them, I can select which ones do I really want to see. So let's say I just want the last 3 because I had high aspirations there. You can change around your dashboard. You can poke around and see different values. You can configure the panels. The other part of training your model is also having a nice insight into the data. So if you're curious about that, these charts come from a lot of runs. We have something called tables, which I like to think as pandas data frame on steroids. So you can also play around the table. You get this nice data that's captured, and you can also query, group, and do different things around here if you want to get more insights out of this. So far I've talked about capturing your experiments, capturing your model details, architecture details, your data sets. The last piece of the puzzle to me is being able to run hyperparameter sweeps. So as you can see, we give this nice view. I keep saying we because I've just been running the examples for this demo, and it's been made by my incredible colleagues. So this showcases you different sweeps, hyperparameter sweeps that you can run. And these are through Bayesian optimization. I believe this is open source on our GitHub as well, if you want to check it out. If you run a new sweep, it also suggests parameters that you can run through. But the nice thing about this is you can just set this to run, and after you're done, you can quickly see, okay, this was the best sweep or model configuration that had the lowest loss. And now you can poke around Frosty sweep 2 and see what the parameters were there. Now, finally, I'm ready to write a blog around this, and I don't want to export these plots, right? So I can just hit click report, create report, and that basically allows me to just write a blog around all of this. I should probably refresh the page real quick. I had this open for a while. Sometimes this happens. That is not ideal. I'll have to report a bug. I wanted to showcase that you can write a report around these. And the cool thing about sweeps, as we call it, hyperparameter sweeps, is you can run these across multiple machines as well. So as you can see, I was just running this on one Colab notebook, but if you had multiple machines, you could also run these across the same. So I know they're much smarter people than me in this call. That's why I wanted to give a quick overview and spend more time diving into different pieces. So now I leave the floor open to any questions.
Can I ask a question again?
Please.
Sorry. So you mentioned multiple machines. So I can think of sort of 2 ways that I've been working with multiple machines. One is if you use AWS cloud system or something, you might launch multiple machines to run a series of experiments. And the other is we have a queuing system, Slurm, at the university, which allows you to connect to machines and send bash jobs. So is there sort of any support or how would you suggest working with multiple machines, for example, when we're doing hyperparameter sweeps?
Yeah, absolutely. I'll just point you to the documentation, but it's absolutely possible with like minimal configuration. So I'll drop this in the chat, but from here you can find all of these details and also nice videos around it. Please let me know if this doesn't help. I'm happy to come back and answer any questions.
Thank you.
And also, can we go back to TensorBoard question again and compare those 2?
I don't strictly have a one-to-one comparison, but I should mention that this is a more holistic picture where we're trying to not just capture experiments, but also log your data sets, be able to run hyperparameter sweeps and different things. So it goes a bit beyond that.
I see, but in TensorBoard, everything is saved on the local. And as far as what you are showing us, is there is like a dashboard connecting all of our data. Is that right, or am I?
Exactly.
thinking-
It is also possible to host this locally. So if you're working with sensitive data, you can self-deploy this as well. But that's a nice thing, because to me, I sometimes work across multiple machines, so it's easy to log across different machines. Like if you have a queuing system across different, I assume, clusters, then you don't have to reinstall the package everywhere. I'm sorry, redeploy the package everywhere. You can just log it to a central dashboard, which you can then check on your phone, and you don't need to be connected to the machine.
Thanks.
Can you monitor the GPU allocation system tab? Yes, you can. I was running on Colab, and Colab now hates me because I've I've been running non-stop demos for a while. Ideally, it should be captured if you get GPU access there. So let's see if this one had any. Yep, you can, as you can see, your GPU utilization is also captured. And as I mentioned earlier, right? So if this dip is happening many times, you might want to investigate your code then. I'm not the kind who benchmarks his code and is always smart about it. So I let it run, and then I do this retrospective investigation where if I see it's not being utilized well, then I try to figure out what's going wrong. Dennis, please go ahead.
Thanks. So going back to Fatma's question, if we were to try to add some support for an unsupported framework in an unsupported language, what kind of effort would that take?
Are you referring to Julia, or which language
Julia
do you
and
have in?
Knet in particular, yeah.
I remember someone at Julia has a port of some sort working with this right now, so I might have to check on that.
Okay, that would
I'm
be
not too sorry,
interesting.
please.
Yeah, that would be very interesting. I would actually be interested in contributing to that development if there was something missing.
I need to double check on that. I might be wrong because I might be mixing two things. I'm not sure how much effort it'll take to develop that. But for an unsupported framework within Python, it's basically as simple as logging stuff, right? So if right now, if I show what all frameworks are supported, this means for all of these frameworks, we have callbacks built in where you just add one callback and basically everything is captured. If you're not working with either one of these, you can just call the want_p log function every time you want to log something, and it's taken care of. So again, it's some overhead, but you'll just have to make sure you log that dictionary or send that data to your dashboard in Python.
Well, thank you.
Awesome. I'm reading the question by Abdul.
I don't think it's for you, Sanyam. Maybe it's
Okay.
a general question, yeah. Sanyam, actually, with Nazir, we had an issue. Nazir, do you want to ask him about this very large figure we had at some point, and then, like, it was not possible to visualize it on the browser, but maybe it would be possible if we download it, right? Like, is there an option to use it like that?
So there are these built-in supported if you, for example, want to log a confusion matrix or like a precision recall curve and so on, which are, like there are some functions which are specifically implemented in weights and biases. So basically, it provides several versions. For example, there are two versions of like confusion matrices. You can use the one which is built in, and you can use the one from scikit-learn. So one thing is that we had, like, for example, more than 10 classes, let's say 20 or something classes. The thing is, because the size of the number of classes increased, and the figure is bigger, we weren't able to find a way to to, let's say, make the size of the graph suitable for visual reading, and also not being able to download it in a like readable way, essentially. So yeah, I mean, these are so. This is so. Do you have any like recommendations on how to customize basically the built-in features such as this?
I might have to think about it and get back to you. That's a great question. I know it should be possible to tackle it. I just haven't had the chance, so I'll get back to you after this session with an answer.
Sure.
Any other questions or thoughts by anyone?
Okay, no questions, I guess.
Awesome. I can quickly run through an end-to-end demo that I thought we might not require, but I still have it open. Let me share my screen again. So again, this is straight from the documentation. I'm again skipping over a lot of details because I assume everyone would be familiar with a lot of those things. So I'll glance over, but again, happy to take any questions. So this is how you would get started in PyTorch. So for someone who's completely new to the framework, in pseudocode and also in Python, it's pretty much the same thing. So all you have to do is import the framework. After, if you're in Colab, you might have to pip install it. And from there, you need to initialize the project, set the configuration. So this is similar to also logging in a foreign framework, right? You might want to manually set these configurations. And from there, you can grab your model and data loaders, set a track of gradients. So someone asked me if it's possible to capture these details. It's absolutely possible to capture them like so. And inside of this, I believe we're training on MNIST, unless we've changed it recently. No, it's still MNIST. So this is a very vanilla demo of a simple CNN model on a MNIST, on the MNIST data set. I know it's the hello world for you all, and I apologize. It's a simple data set. So again, importing the standard Torch Vision modules and everything vanilla. We start by pip installing weights and biases. From there, you have to log in, and let me connect real quick. So once you log in, you need to grab your API key from your dashboard, which it prompts you to enter. I think I ran out of the active session, which is why this might have gotten disconnected. I can run it afterwards. So once you enter your API key, you can set your configurations like so in a dictionary, where you can enter how so many ever epochs you want to run for, how so many classes you want to train on. Again, it's MNIST, so it's 10. All of the standard details and the data set and architecture. From there, you can define your overall pipeline. So you can tell what weights and biases to initialize the project. Let's call it PyTorch demo. You can log the configuration, which is basically your hyperparameters. From there, you set the data and optimizers, and call the model that you want to train and return the model. After that, you can quickly define the pass on the config dictionary to 1DB init. And we call the data set from here. We define a get data function that captures your training data set, set up the training loader, the test loader, again, standard stuff with PyTorch I'm glancing over. Call a vanilla confnet and set to cross entropy loss, because again, it's a classification problem. And I believe that is all that you need to capture all of the information. You might have to call 1B log afterwards, or you can set watch if you want to track the gradients. Otherwise, just calling 1DB log whenever you want basically logs all of these details and whatsoever is going on to your dashboard.
What's the difference between watch and log?
Watch allows you to basically log gradients and parameters, I believe. Is that not helpful?
Yeah. Thank you.
Amazing. I'm skipping over the fine details, which I spend more time about explaining connets and everything, because I know the audience is quite advanced way.
Great, Sanyam, thank you. Who is actively using WAN-DB right now here? Except Nazir, maybe. In addition to Nazir. Canberk. Canberk, are you using it with PyTorch?
Yes, I'm using it PyTorch.
Okay, who else? 2 people. Who is thinking about it? Abdurrahman is using. Nice. Gürkan is thinking about it. Abdurrahman, do you also use it with PyTorch?
Yes, we use it as like commercial approach in the startup we working at. So in every trial that customer try to train each model, we watch all the losses and the weightage, and also we kind of related it to the product that we are working on.
Nice. Okay. Okay, more people are thinking about it. That's a good thing, I guess, Sanyam. Thank you.
I should also mention, we usually cap for teams the usage. It's absolutely free for academic users. So you can find more details on the website if you're interested in that.
Okay, there is an interesting comment from Ege. I'm thinking about using it, but I don't want to migrate from TensorBoard for the current project, probably for the next project. Is there an
Maybe I wasn't convincing enough. I apologize.
No, you are, but is there an easy way to migrate this from TensorBoard to WAN-DB, or like any reason Ege should put the effort?
Honestly, I haven't used TensorBoard as much, so I'm not too sure.
Here I would like to say something. One reason I decided to use weights and biases over TensorBoard is basically because it doesn't run on your machine. You know, I tried running TensorBoard earlier on my machine has like very little RAM, so it used to take all the RAM basically, and I could not like scale what kind of visualizations I was. So I thought one of the main reasons that because everything is hosted on the cloud, that made it maybe the more like preferable solution to TensorBoard. Yeah, so that's it. That's what I want to add.
Janar says that he has the same concern, and additionally he says that local one requires Docker, which is hard to set up in our cluster. Nazir, you are not using it on the cluster then?
No, I'm using it. I'm using the online
on
dashboard.
The workstation. Canberk, you?
Same for me.
Same for you. Okay, Sanyam, what about clusters? What should we do to be able to use it on the cluster?
Well, we use it as on primes. So we took the Docker image, and with Kubernetes, we built it in our servers. So we can duplicate or use any version that we would like to do. It's also doable to be downloaded and built using Docker in the local machines. And it does take just 2 lines.
2 lines.
Yeah, I think I had this paranoia around Docker as well. like I was joking. So it's fairly straightforward to set up. I think the comment was around they don't want to set up Docker yet. Also, if you're logging it to the central dashboard, it doesn't eat up that much of network bandwidth. So it's like, think of it using lesser bandwidth than how much you would use to download your model weights. Although if you capture your model weights, you will have to upload them. So a few 100 megabytes for larger models, but not too much for just tracking your experiments.
Yeah, Janar says that we cannot set up it easily on the cluster. Janar, you cannot, but maybe the IT can do it for us if we can ask them, right?
That's correct.
Yeah, that should be possible.
Mm-hmm. Any downsides to that? Anyone? Maybe Sanyam won't mention it, but
No, I'm happy to be transparent. I'm not too sure about. The only problem with me, I was like scared of deploying it on my local machine, even though it's not a cluster. And then someone told me if I mess that up, I'm obviously doing something wrong. So these installation steps are fairly straightforward, I think. But if you need help, I can please do reach out, and we're happy to help with that also.
We will. I just realized I took the moderation thing. Nazir, sorry.
It's okay. No worries.
Any other comments, questions? Okay, Sanyam, anything you would like to add? Oh, Deniz Hocam, go ahead.
Well, I have some, technical detail questions from an implementer's point of view that would not interest most of the users, like the underlying architecture, whether it's uses, multiple threads, or does the training have to interrupt to send, communicate with the server? How does the server client architecture work, etc. But I think it would be better if I ask those questions after I read the documentation and without taking everybody's time. So Sanyam, you can expect an email from me in the near future. Thank you.
Yeah, happy to help you there. From what I understand, again, I wasn't involved in this development, but I remember the team actively discussing the fact that they always monitor how many resources do we consume just to track the stuff, and it's really lightweight in that way because we don't want to get in the way of training your models. I'll be honest, we do see some bugs here and there, but the team is like absolutely fast on fixing them, and that's how I came across these conversations.
Zainab has a question about tracking time limits.
They don't apply to an academic team, so we, I believe, have some limits around team timings where you can only log a certain hours of GPU experiments across multiple people. But for academic users, there's not a cap.
Do we need to apply for it, or is it automatically detected by the email? How does it work?
I'll have to double check again. It's all available on the website.
Okay.
Sorry, I didn't have that info offhand.
That's okay. No problem at all. Zainab. Okay, great.
I'm curious, is anyone using JAX at all yet in the lab or no?
I don't think so, but I would be curious to know too. I'm curious about it. I would like to learn at some point, but yeah.
We're hosting a series of meetups around it. So they're like, I think 4 or 5 meetups available on the YouTube page, if you're curious.
We'll check it out. Gürkan, go ahead.
So Sanyam, why should we use it, or like why do you think it might be helpful for us to use JAX?
Great question. I don't have a good answer. I was just curious if anyone is using it. To me, the really interesting bits were accelerators. So it works really well with minimal changes on TPUs and multi-GPUs. On the cloud, if you have like different setups, so I have like different sets of graphic cards, then you might have some problems. But just that ability to run on any accelerator, and TPUs are really fast if you can parallelize across 8. I think it's 8 in a TPU pod that you get on the like simplest one, even in Colab. So that is interesting, but again, there's this trade-off that you might have to run around rough edges that aren't coded already.
Yeah, we don't have any TPUs currently. No access to TPUs yet.
Isn't there a research program that everyone can apply for?
Yeah, if Google is listening to this. We applied many times, Sanyam. Okay, any other questions? Yeah.
I don't know how Ali is doing it, but my student Ali keeps getting TPU hours from Google.
Oh, is Ali here?
Hi. Yeah. Yeah, actually, you just send them an email to the TensorFlow Research Cloud program. Basically, you can say that like the quota that they provided wasn't enough for your research, or there's an additional research that you want to do, and they just provide the quota. And actually, interestingly enough, I asked them for more credit and they gave me credit as well. So like the credit that you can use for storage, etc. So yeah, but you need to maybe like mention the project that you're working on and show them some results at least.
I think they're quite open to, I think it's called TFRC program. If you just look that up, they're open to giving credits if you have like a good enough use case that you want to try out. I mean, if I was able to get access, other people in this call should be able to get access.
That's the wrong assumption, Sanyam, but thank you for the encouragement. Because we tried. Okay, any other questions? We are done early. Thanks a lot, Sanyam. That was great, very helpful. And we are looking forward to the recording.
Thank you so much again for letting us be a part of this. I'll quickly drop the links in the Zoom chat and I can email this as well. Fun community effort that might be of interest to people in this call. We run a monthly paper reading group, and there's a repository that I'm trying to develop in my free time, which has annotated papers. So any thoughts or suggestions there are really welcome, but the idea is to annotate papers, interesting ones, and to the best of my knowledge, just share any stuff around that. So
thanks, Sanyam. Thanks, everyone.
Awesome.
Thanks, Nazir.
Thanks, everyone. Thanks again, Fatma.
Thank you so much for the session. Yeah.
See you.